Hello students, in this video I'm going to talk about significant figures. I think you are already familiar and you have worked with significant figures, and you are aware that whenever you are doing calculations and whenever you have to arrive at your final answer, then you have to write the final answer according to the significant figures which are required according to the problem. So what are these significant figures? How do we arrive at significant figures? And what are the rules that govern the addition and subtraction and the multiplication and division involving significant figures? That's what I'm going to tell you in this video, and it's going to be very helpful to you because you need to use this concept throughout your calculation work in chemistry. Okay, so going ahead, what are significant figures? So I think it is best illustrated with an example. See, for example, here we are measuring the length of a pencil using a ruler, and this ruler is graduated in centimeters. This is 1, 2, 3, 4 centimeters, and 1 centimeter is divided into 10 equal parts, so that each division is equal to 0.1 centimeter. And since the uncertainty is half of the smallest division, so it is 0.1 divided by 2, that is 0.05. So now let us see that if we have to write down the length for this pencil using this ruler, what we are going to write. So this whole figure has been enlarged so that you can see it more clearly. Now it is clear that the length of the pencil is 6.1, 0.2, 0.3, 0.4. So it is more than 6.3 but less than 6.4. So we can write the length as 6.3. Now these two digits, 6.3, we are quite certain about these digits, but the next digit we are not certain, because it is definitely not 6.4, but in between 6.3 and 6.4. So it appears that it is 6.35. That is our estimate, that is our guess, and we cannot write any digit after this digit because this digit itself is uncertain. So when you write these three digits, two of them are certain, but the last one is uncertain. So when we write the figures in which only the last figure is doubtful or uncertain, then all these digits together is called as the significant figure or significant figures for this measurement. So these two digits are certain, the last digit is uncertain. So you include one last uncertain digit and then you get the total number of significant figures. So here in this case, the measurement is 6.35 centimeter, which can also be written as 6.35 plus or minus 0.05 centimeter. But if you don't write this, it means that this is the uncertain digit. All right. So this is the concept of the significant figures. So similarly here, if you see how we should report this temperature, so 23.6. So here these two digits 2 and 3, 23 are certain, but the last digit is uncertain because it may be possible that it is slightly more than zero point 0.6 but less than zero point 0.7. So it is not showing us 0.7, it is showing us only 0.6, but it could be little more than that. So that means this last digit is uncertain. So including this last uncertain digit, we will write 23.6, and we cannot write anything after 6 and therefore there are three significant figures in this measurement. Similarly, here the value for the mass is 19.972, where the last digit 2 is uncertain because it could be slightly more than 2 but less than 3. So here we are having 5 significant figures. So as you understood that when there are no zeros and there are all the non-zero digits, then it's very obvious that we have to count all the digits as the significant figures, for example 3 or 5. But when it comes to 0, then the rules have to be understood, because then it becomes difficult to decide that whether the 0 is significant or not. So there are certain rules which are given in your textbook or in your notes, and you can refer to that. I'm giving you the example. So the zeros appearing between non-zero digits are significant. Now see, in this example, 40.7. So this 0 is appearing in between 4 and 7, which are the non-zero digits. So zeros appearing between non-zero digits are significant. That means this 0 is significant, and therefore there are three significant figures in the measurement 40.7 liters. Now look at the B example, where again these two zeros appear between 7 and 9, which are the non-zero digits, and therefore these zeros are significant, and therefore the total number of significant figures here is 1, 2, 3, 4, 5 kilometer. So it has 5 significant figures. Now, zeros appearing in front of all non-zero digits are not significant. So now look at this particular two zeros which are appearing in front, not in between, but in front of the non-zero digits. So if these numbers are in front of the non-zero digits, then these zeros are not significant. So here the number of significant figures is 1, 2, 3, 4 and 5, and you will not include these two zeros. Similarly, you will not include all these zeros because they are appearing in front of a non-zero digit, and therefore this measurement has only one significant figure. Okay, so now here, if the zeros are at the end of a number and to the right of a decimal point, that means 85.00. So these zeros are after a decimal point. So when the zeros are after a decimal point, then these zeros are significant. That means this has four significant figures. Now look at this. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, and all these zeros appear after a decimal point, and therefore all these zeros are significant. So including the 9, there are 10 significant figures. Now, if there is no decimal point, then how do you decide about the significance of zeros? So there are different rules for this, but the most common rule is that if there are zeros and there is no decimal, like for example here there was a decimal and then there were zeros, so these zeros were significant, but here there are zeros but there is no decimal point, so you will not consider these zeros as significant. Therefore 2000 has just one significant figure. So these are most common rules that you have to understand when you have to decide about the zeros, whether they are significant in a measurement or not. If there are non-zeros, then all the non-zero numbers are significant, so there is no problem about that. Okay, so we can just look at a few problems. to further understand the concept behind the significant figures. For example, if you look at this, then how many significant figures? I think it is easy to decide. There are no zeros, so all the numbers are significant, and therefore there are three significant figures. Here there is a decimal, and therefore this zero becomes significant, and therefore there are four significant figures. In this, there is a zero in the end, but there are no decimal points, so this zero will not be considered to be significant, and therefore it will have only two significant figures. Here a zero which is in front of a non-zero digit, that means this 0 and this 0, these two zeros are not significant, but this 0, because it is in between two non-zero digits, therefore this 0 is significant, and the non-zero digits anyways are significant. So total number of significant figures in D is 1, 2, 3, and 4. So 4. Now here the zeros in front of this number will not be significant, and these zeros are occurring after a decimal point. Therefore these zeros will be significant, and therefore the total number of significant figures here will be 5. So that is the way we decide about the significant figures, right? So in the same way, if you decide about this, then you can easily compare the answer and find out how many significant figures. For example, if you see D, then there is only one significant figure because there are no decimal points, so these zeros occurring at the end are not significant, so only one. These two zeros, because they occur between the numbers, are significant, so there are four significant figures. This 0 is not significant, this 0 is not significant, so 1, 2, 3, 4, 5, and 6. So there are 6 significant figures, and here because these zeros are in between the non-zero digits, so they are all significant, and therefore there are 5 significant figures. So this way you can decide. And now there is an interesting question that suppose the value of 7,000 centimeters is reported to you. How should the number be expressed if it is intended to contain one significant figure, four significant figures, and six significant figures? So let's try this out. So now we have to write 7,000 and it should have only one significant figure. So obviously our answer should be 7 and 1000. So 7,000. So these three zeros will not be significant, so it is only one significant figure. Four significant figures will be 7,000 with a point over here, and six significant figures will be 7,000, and then there will be two more zeros, so it becomes all the zeros become significant because there is a point, and these zeros are significant as well as these zeros are significant. So 1, 2, 3, 4, 5, 6. So even though all the numbers are 7,000, but they have different number of significant figures. I think you understood this, and going further, how do we use the significant figures in calculations? So there are two simple rules that if you add the numbers which have decimal points, and for example we are adding three numbers. In the first number there are two decimal places, in this number there are three decimal places, and in this number there is only one decimal place, right? So when we add in the normal way we get 104.842. But this will not be the accepted answer because the rule says that during the addition process, the final answer should contain only those many decimal places which are there in the number having the least number of decimal places. So here, because the smallest decimal place, only one decimal place is going to what is going to decide the final answer, right? So if the final answer should also have only one decimal place, so but after 8 we have 4, so if you round it off, then 8 remains as 8, and therefore the final answer is 104.8, right? So we have to write only one decimal place because the number which has the least number of decimal places has only one decimal place. So that's where you have to add the numbers which have certain significant figures. And now when we multiply and divide the numbers which have different number of significant figures, then what should be our final answer? So we have to now look at the fewest significant figures, not at the fewest decimal place. Here we have to decide according to the least decimal place. So one decimal place. Here we don't have to look at all the significant figures but only the decimal place when we are adding or subtracting the numbers. But when we are multiplying or dividing the numbers, then in the final answer the number of digits is decided by the number of significant figures in the lowest number that you see, that is here 5.2 is having this number has two significant figures, this number has four significant figures, but our answer should have only two significant figures. So obviously our answer should be just 32 because this 0.3 less than 5, so this will remain as 32. So our final answer will be 32 centimeters square because of two significant figures which we have to consider out of these two, which is the least one. So I think you understood, and sometimes we have to round off, and you know that for rounding off, like if we have to round to three significant figures, and if the number following the third significant figure is greater than 5, then this number gets increased by 1, so it becomes 42.7. But here it is less than 5, so it remains as 3. And here because once again it is 5, so this also gets increased by 1, so it becomes 2.79. So this is a simple way of rounding off which you will be learning in your calculations part. So I think you had a basic understanding of what do we mean by significant figures, how do we decide how many significant figures we should report in our measurement, and how do we add, subtract, multiply and divide using numbers which have different numbers of significant figures. Hope you understood. Thanks for watching, and if you liked it, please give it a like and give your comment. Thanks a lot for watching.